Kyle, you can cut that music if you want. There we go. Are we rolling? Are we live? We're live. Welcome to Chat, everybody. Give yourself a round of applause. Go ahead, let's warm the room up. There we go. Proud of each and every single one of you. That's right. Okay. So we got Camilo today, and he has this really great bio. I don't normally read the bios, but I'm going to do that today as a way of introduction. So Camilo rose from the swamps of South Florida, where he taught the alligators PHP and Vim. He traveled the Sahara with the Tuaregs of Morocco. Did I get that correct? Okay. And found the solid design principles etched into glass beneath the sands. He then moved from Miami to Chattanooga to teach what he could and receive the wisdom of the ascetic programmers of Appalachia. I want to meet them. Whether or not Camilo received a computer science degree from Florida International University remains a hotly contested debate among his biographers, critics, and acolytes. So everybody give Camilo a round of applause.
Okay. Great, cool. So I'm Camilo Payan, that was my intro. And yeah, I'm here to tell you all about the Language ServerProtocol. It's a pretty cool innovation in language tooling, and I hope you have fun learning a little bit about it. I had a lot of fun researching it. There are a lot of people excited about this. So to get an idea of where we are, first it makes sense to kind of get a state of language tooling as it exists right now. And when thinking about it, I kind of came up with 3 tiers of language tooling. One is there are company-backed languages. There are popular languages that are more community-based, and niche or new languages, which are in a different state. 3 tiers. So starting out, we have these company-backed languages. And these are languages like Java, like Swift, Objective-C, C#, all the .NET stuff, Kotlin nowadays. And I guess let's see with a show of hands, who is already using one of these languages? Nice, a lot of people. And how many of you are using IDEs to code in? Right, pretty much everybody, because that's the best way to code in these languages, by far. IDEs are pretty great, and they're backed by a company who keeps on coming out with new features. So you've got things like NetBeans, Xcode, and Visual Studio by Oracle, Apple, and Microsoft, respectively. The downside to that is that you have kind of a vendor lock-in going on. So not only are you kind of locked into the IDE, but you're also locked into usually, well, it used to be this way, though I'm learning it not so much anymore, the operating system as well. So Xcode only works on Apple machines, on Mac OS. Visual Studio used to only run on Windows, but very recently they came out with a Mac OS version. But for example, you still couldn't run it on Linux. But the trade-off is very, very good, because IDEs have tons of features. The kind of basic things that you would expect, like code completion, linting, getting the errors. These are, frankly, more work than you would expect, but they're all there in the IDE, as well as more sophisticated things like refactorings, renamings, code exploration. You can get a stack of your types. You can get a stack of your functions. IDEs are great, and everybody who uses them knows that. So how does the IDE do all that? I mean, it's pretty hard to get this kind of functionality in other environments. Well, they use a compiler. The compilation is necessary to get a set of objects that reflect the reality of your code, and that's how they get such rich knowledge of the languages themselves. On the other hand, that can add extra work that is impossible for a community to do. Not impossible, but very improbable for a community to do. So for example, Eclipse maintains its own Java compiler. Why? Because Java-C, the Java compiler that Oracle comes out with, is geared toward running on the JVM as quickly as possible, and it's really good at that. It's not as geared toward the features that you need for an IDE, so they have their own incremental Java compiler that gives the information and data that you need for Eclipse. Now we've got popular community languages. These are languages that started out kind of set usually by one person or one creator, and reached a critical mass in terms of popularity and now have pretty good tooling. So these are things like Ruby, Python, PHP. And JavaScript is kind of an odd duck here because it's so ubiquitous, but it's still pretty much true. There's no one company that has ownership of JavaScript, no matter what Joyan tried to do. So how many people are using that in their day-to-day? Right, they're very popular, especially with web development in question. And these usually rely on a general purpose code editor of some kind. You're looking at Vim, you're looking at Sublime, TextMate, Emacs, if you're into that. So the kind of gap that they've created, though, is that those code editors don't necessarily have these rich language tools built in. They can do like syntax highlighting, but they won't be able to get you refactorings out of the box. And then for everything else, there's usually nothing. You've got a code editor and you have language-specific configuration, so you're going to get things like syntax highlighting, not from something that understands a language, but from like a syntax file is what we use in Vim and in other languages, some kind of configuration file that has that all done for you. And you'll probably get it off of somebody's GitHub. That's actually my setup right now. I code in PHP, but I don't like PHP Storm that much, which is the kind of the best PHP IDE out there. But I've set up syntax highlighting in PHP. I have like 2 plugins that come in just to shim the differences between the latest version of Vim and the newest version of PHP. And then I use Unix C tags to jump around and explore my code base, and everything else has kind of, I fill in the gaps as I need to. But the truth is, it's usually good enough to get your work done, especially with something like PHP, where you can easily keep on running your code again and again just by refreshing the page. In the last decade or so, we've had a lot of people come up with a combined approach where we have the text editor approach because people really love these text editors. And there are different opinions on how you should go around in a file and edit, combined with the kind of rich information that you get from modern compilers. So to give you a couple examples, Jedi is a really good plugin for Python. The static analysis tool for Python gives you auto-completion. It can give you, I think, some basic refactorings now. And what it does is it's running as a back-end service, and then your text editor of some stripe will go back and forth with it. Is anybody using Jedi? Right, I know you. Turn is kind of the same deal for JavaScript, and that's interesting in its own right, because JavaScript isn't a compiled language, it's an interpreted language. So why are we compiling it? Because that's how you get static analysis done. This one I'm really curious about. Is anybody actually using Turn to write their JavaScript? You like these? Okay. And then there's OmniSharp. When the Roslyn compiler, a cross-platform compiler for .NET services came out, they started work on OmniSharp. It supports IDE, refactorings, code completion, and so on, and it's made to be usable in any editor. Moving on a little bit in our history, this is Visual Studio Code. It's a Microsoft product released about 2 years ago. It's cross-platform. It runs on any platform because it runs on the Node runtime, the Electron runtime, and it's a general code editor. So the problem that they ran into very quickly is when you have a general code editor, you got to support a lot of different languages. And while that's not necessarily a problem, it is a lot of work. So their solution was a language server protocol. So what is a language server protocol? It's set up as a joint project between Microsoft, Red Hat, and CodeEnvy. It's based off the same kind of work that we saw with Jedi and Turn. And the history of it is kind of interesting because they started off with OmniSharp, getting C# and OmniSharp working in Visual Studio Code. Then another Microsoft product, TypeScript, a superset of JavaScript that compiles to JavaScript. They needed that working in Visual Studio Code, and just like most good programmers know, you solve something once, you solve something twice, and then you solve something for every case, because what's the point in continuing to reinvent the wheel? So the language server protocol defines a language server, as you'd expect, which has, they don't care about how it's implemented, but it has a rich knowledge of whatever language it's supposed to be looking at. And then it makes those pluggable. So any language server, any editor with an LSP client can plug in with any language that has an LSP server and work out of the box. So I've got a little demo, kind of a contrived demo. This is a FizzBuzz program, the worst lasagna code FizzBuzz. So I have, we all know, so is anybody familiar with the FizzBuzz interview question? If it's divisible by 3, you write out the word fizz. If it's divisible by 5, you write out the word buzz. If it's divisible by 3 and 5, you write out fizz buzz. And by it, I mean all the numbers from 1 to 100. So if you have an interview coming up, take a picture. But not of this. So this is a strange one. Can everybody read that okay, or maybe a little bit bigger? Right. So what's happening here? I set up an interface for checking whether or not something is FizzBuzz compliant or whatever. And then we have our concretions. And this particular language server isn't super powerful. It has 2 things going on for it. It has auto-completion and it has go-to-definition. So we can check that out here with, if I wanted to check this interface out, I can right-click, and that's very hard to read, but it says go-to-definition, and takes me over to my iChecker interface. That kind of knowledge is already a big step up from what I currently get from CTags, for example. What that would give me is, if I had more than one file named iChecker, it would give me a list of all of them, and then I'd have to choose, which is fine, but for example, in my code base right now, we have maybe 70 files named loader, so it's kind of hard to dig into the list. Because I'm a good object-oriented programmer, when I'm writing my FizzBuzz checker, I didn't rewrite fizz and buzz. I realized that those were both repetitive, so I went ahead and put instances of fizz and buzz checkers into my FizzBuzz checker. And what's good here is it gives me the auto-completion that I expect. Check num. So that's just a very short and small demo of how the Language Server Protocol looks when you're using it. There's a language server behind this called Crane, and this is Visual Studio Code, which is where this all started. So let's go back. How does all this work? The real foundation of this is the language server itself. So language servers can be written in any language. They have to use the same endpoints that we're going to define in a little bit. And they can be written in any language as well. So a lot of them are written in TypeScript because TypeScript runs automatically in Visual Studio Code, and that's the main market for this. There's also the Rust language server, if you might have heard of it, which is actually how I heard about this in the first place. And that one's written in Rust. I've been toying with the idea of writing one in PHP for PHP because there's a good PHP parser now, but if anybody wants to help me with that, that would be great. Oh, I did not switch back. There we go. So the first thing that happens when you're working with an editor that uses the Language Server Protocol is it's going to connect to the language server. The reason why that is not every language server is created equal. They define a certain amount of capabilities, but not every language is going to need those capabilities, and servers are in a different state of doneness. They might not just have all those capabilities done yet. So the first thing that happens is it'll send back the client those server capabilities. So maybe this one can only do auto-completion and go-to-definition. Now the client knows that. When it has a question about go-to-definition, it's not even going to bother looking at that language server. Which brings up another good point. You can have more than one language server running. So if you're jumping around from language to language, there's no need to spin them up and shut them down. They're all going to be running at the same time. They're all going to get the same request. But it'll decide the appropriate one when the request comes back. And we can take a look at how a regular editing session would probably work. So the user opens their document. They send a message over to the language server saying it did open. The reason for that is you want the server to know that what's in the file system is now a lie. It doesn't matter. It's only the stuff inside the editor that matters. User starts to edit their document. They send when that happens, they send a did change request over to the server, and then depending on what the server has available, it might send back, in this case, diagnostics. So that's errors and warnings and things like that. And depending on your client editor, that'll show up a different way. Maybe something in the sidebar, maybe something in a bottom bar. Then they run a go-to definition. In this case, it's not just sending the file along, it's also sending the position. So if we were going over to our iChecker, it would send not just the fact that it's in FizzBuzz checker, but also the fact that it's on line 3, column 30. And then when we come back from the server, it's going to send the iChecker file URI and the line that it's on. And then at this point, the user is done with what they're doing, they close it, and that sends a message over to the language server telling it, okay, we can trust the file system again. The source of truth is no longer the editor. And we can take a quick look at how one of these JSON packages looks. There's going to be the method name that it sends across the wire, so did open in this case, and whatever information it needs in there. So this doesn't, it's JSON, but most people would probably think that, like when you see JSON going back and forth, you're thinking of a REST API. This is an RPC API, so it doesn't have that same kind of collections focus. So what are the drawbacks to using the language server protocol? Hello. Well, it boils down to limited functionality. It doesn't define everything that a good IDE could do. A good IDE can do things like debugging, which this doesn't cover. It can do things that we talked about, like the type hierarchy, functions, call stacks, all that inside your IDE. But this won't do that. It's just not part of the protocol. They're really geared toward trying to get that 80% of rich language features while leaving that last 20% up to whoever is actually trying to use this. The other downside is that it's not extensible beyond what's defined in the protocol. So that kind of makes sense. You want to make sure that things are compatible, but it is a real downside. So if you do want the things that aren't inside the protocol, make sure to have that set up in some other way. All right, cool. So how can we use it now? There are 4 real implementations. There's one in Eclipse and another Eclipse project called Che that I haven't heard of. Visual Studio Code has the best implementation right now, and it's actually very easy to get started with it. They have an extension marketplace. You go in, everything is in a registry there, and you just download it straight away. And then there's also a NeoVim implementation, and there's work to move that NeoVim implementation over to Vim, but it's not quite there yet. And which languages have servers? This is a list of languages that have servers. These that have stars next to them, JavaScript and TypeScript, are the languages with every feature of the language server protocol implemented. And then C and C++, Crystal, these are both work in progress. You can find out more about that at langserver.org. So it's a tracker site that's community run, community updated about the LSP. And they have a lot of information on exactly where these are in terms of development. So that was a shallow dive into the language server protocol. And thanks.
There he goes. You may have mentioned, but I missed it. Is the language server something you install on your own machine?
It depends on the setup. So like Visual Studio Code, for example, has their thing where you can just kind of, it's an extension. So you can look around for, in this case, it was one by Heavy Industries called Crane. I tried to get this working with NeoVim and got frustrated and stopped. So that one's a little more heavy lifting, as you would probably expect. But yeah.
Other questions?
So, I mean, besides go to definition and the auto-completion, like, what are some other common useful things that it does include?
Best list of that. Show you langserver.org. So this is a big table of languages. But yeah, so diagnostics is a big one. Getting your warnings and errors for everything. Some of these felt like they were repeating themselves, like find references and jump to definitions. But since they're kind of, the other direction of the same thing. But yeah, so this is pretty much what it has defined. Yeah.
Thanks.
Others? Yay? Nay? All right. Camilo, you'll be around afterwards, right? If you want to chat more about this. Yeah. Everybody give him one round of applause. Yeah. Thanks. Appreciate it. You guys come out. Andrew, are you here this week? Andrew Steele's going to be talking with us about building a game in React, so that'll be a fun one.